Hello, it's Andy here. I'm with Daniel. We're here to show off the AltMill project that we've been working on since 2021. We've put it on the back burner for a little bit, and we'll talk about how that came to be. But now that we've moved into this new shop and we have all the extra space, we started working back on the AltMill again. So today we'll be talking about what we've been working on, what the project is, and what you should expect in the next couple of months. So yeah, let's get started on that. I think the first thing to kind of recap is what the AltMill is. And there's kind of several different, influences for us to decide what the machine is going to look like and what it's going to do. So the first thing, probably the most main thing that our long mill users have complained about is the V-wheels and the lead screws. I think the main complaint is they're finicky because you got to adjust them. They're good for hobby use, but they're kind of a weak point of the machine in terms of how rigid the machine can be. And then the second is with the lead screws. Although the lead screws were a solution for a lot of the machines that used belts at the time we designed the long mill, one main kind of irk is that you got to adjust the nuts to give up the backlash. Yeah, so with the AltMill, we've included the hardware that basically eliminates those type of problems. I will note that we have developed the spring-loaded anti-backlash nut, which you can read about in our other production updates, which will eliminate a lot of the lead screw related issues. But primarily that was the first kind of influence. What's the best way to make a machine that was going to be as perfect as possible, essentially. The second thing is that the long mill, it kind of sits in the entry-level beginners market. Some of our users, they wanted to upgrade to something. They like the simplicity, they like the design philosophy, they like the workflow, and they like the community, but they wanted something that was bigger, that was faster, more powerful, because the majority of long mill users, they've never used a long mill, a CNC machine before. Based on our communication with our customers and also surveys, most people, they get into it as a hobby, but in the back of their mind, they're I could maybe make a business out of this. I've seen a lot of people who have started with making projects, and then people will see oh, can you make a sign for me? Oh, there's a product that people might want to buy at a holiday shop or something like that. Yeah, we've seen people who start off their CNC journey with us with a long mill, and they eventually get a second one and they start to make money with it. They quit their jobs and they become their own business doing it. Or some people, they are in semi-retirement and they kind of work with the long mill to provide something to do, a supplemental income, pay for toys, so on and so forth. And the last thing is kind of for us to diversify into different areas, because I would say that the AltMill, in terms of price point, allows it to be in the beginner's market, but because of the hardware and the performance that we can provide with a machine like this, you could use it for more intermediate to advanced level production. It's not at quite the level of a full industrial machine where you'd have steel framing and vacuum table, have to run on 3-phase and all that sort of stuff. This can still be used in the shop and things like that. But because it's a bigger and more powerful machine, use it more more reliably, more regularly, and things like that. And the last thing is, a lot of the development that's come into the AltMill is from us learning how to build machines better. So I think our experience in terms of building the long mill, building the mill 1, and building other projects have kind of led us to understand better engineering techniques, use hardware that's more advanced, have better specs, and also understand the production side of things. So another important part about us as a business, there's the cost of the machines, but we also have to produce them in high volume to have a viable business, and also because our goal is to make this technology more accessible, let people be able to get the machines all over the world. We believe that it's the best machine that we can design at this current time based on our experience, but comparing other machines that are out there, I think this is going to be a big hit.
All right, so we'll look at the technical side of the AltMill. Like Andy mentioned, we've learned a lot from the last couple of years with long mill stuff. So we know kind of the two cruxes of the long mill were always the V-wheels and lead screws, like he's mentioned. So these affect performance in terms of rigidity, performance in terms of speed we can get to, and then also reliability is like another big factor here. We'll talk about the performance and the reliability differences or anticipated differences of the AltMill. Performance-wise, we've always known that the V-wheels would make up somewhere between 1/3 to half of the deflection on the long mill. Depends a lot on the tuning of the V-wheels, depends a lot on how much they've worn, etc. So leaving that to chance is kind of not great. But yeah, anyways, the switch over to linear rails should address that. These should be basically a service-free item almost, other than maybe occasional lubrication, but there won't be any adjustment and they'll continue working from out of the box to the end of the life of the AltMill the same way and very robustly. So we've looked at some different types of linear rails. There's these round profile linear rails, there's the square profile linear rails, and you can see this prototype machine uses the round type. The new version, which we'll get to later, will be using the profile type, but these should virtually eliminate any of that serious deflection issues and rigidity issues we've seen with a V-wheel style CNC router.
And just for context, this is like a prototype that we built about a year ago?
No, like 2 years.
2 years ago? Yeah, this is like a prototype that we built a really long time ago. So the new version is like...
It's quite changed.
Quite different.
Yeah.
We put this together to kind of give people a sense of scale on how big it is. And it'll be like fully metal and everything. The actual final production version is not going to look like this.
So yeah, back to the performance side of things. There's a breakdown we've done on the long mill. It's overall a very balanced machine. So ideally you want to have deflection come from all parts of the machine, the gantry, the Z-axis assembly, the V-wheels, etc. And it's pretty balanced. Moving up to linear rails means we want to keep everything else balanced as well. So our gantry needs to be much stiffer, the table needs to be stiffer, we're not relying on a wasteboard for rigidity anymore for the actual machine. These also have all the other secondary benefits of being a lot more precise and precise. Sorry about the noise. And that means that you should be able to unbox it and assemble it to much more square assembly, I guess, and have a lot better accuracy with your cuts. We'll move on to the next, the lead screw alternative, which is ball screws we're moving to now. This is A for no backlash, essentially. You won't have to do any adjustments. There's no maintenance with this other than maybe lubrication, but you won't need to do any kind of finicky screw adjustment. And they'll also allow for much faster operation. So these are 16mm ball screws we'll be going with. It's a very popular size for this type of machine. And these will allow us to run the motors much faster without whipping. We've seen in a lot of long mills, and why it's kind of capped at around 4,000 millimeters per minute. I think that's 157 inches per minute for the American folks. But we're anticipating we should be able to target around 10,000 millimeters per minute. When you get into production work and you get into bigger jobs, obviously actual travel speed is a huge factor. You'll probably end up finding that you aren't limited by machine rigidity so much as you are the travel speed. So we've really wanted to focus on that. 10,000 millimeters per minute should really help with that a lot. Again, I don't know what that is in inches.
It's 380-ish inches per minute, I think.
Yeah, somewhere around that.
A quarter of...
Just under 400 inches per minute.
Yeah.
So you want your travel speed to scale up a lot with the machine's performance in terms of rigidity and the machine size. So this 4x4 bed, you don't want to wait half an hour for it to move back and forth on. You want to get things done. Pairing with those ball screws is going to be likely closed loop steppers. So if you're not familiar, if you've never heard that term before, it essentially just means the stepper motor has a little sensor on the back, an encoder, and it'll tell the drivers of that motor where the position of that motor is. If you've used a long mill or you've used another machine that has open loop steppers, you may have run your machine into the back, you may have bumped into it or stalled a stepper or axle during a job, and that'll usually mean that you need to restart your job from scratch. The machine doesn't know where it is. But if you have a closed loop stepper, the machine will either continue moving to where it thinks it should be and actually understands where it is, or it'll alarm and tell the machine, hey, something's wrong, stop the job, and then you can figure out what's going on your end. This kind of also allows us to get to higher speeds and just have a lot more reliability there. We'll have to get to some more testing of that, but the results should be very, very promising.
So I think people are probably going to ask, like, just to add on to what like Daniel just said, some people ask, like, can't we build a 4 foot by 4 foot working area long mill? It's important for us to like answer that to kind of get context of why the AltMill was kind of built the way that it is. So the first thing about making a bigger long mill than what size it is now is the fact that the bigger the rails are, like the Y rails, as they get longer, if they're off at a slight angle, that's going to be exacerbated the further you go out. So you might be like half a degree out, and then once you're here, you might be like a couple inches. I'm bad at trigonometry, but I think people get the idea.
Enough for some issues.
Yeah, bigger triangle arm, bigger warping, and this is like in all different directions. So like the skew this way, the 90-degree angle on the X rail. So we're gonna make our own rails to put it together. And so one of the things that Daniel's done is like build the rail. These are gonna go here, and then if you can pass me the linear guide.
Yes.
So one of the decisions that we've made for the second version, or the production version, is to switch to the HGH rail system, which is like a lot more rigid than the SBR. I guess like to continue to spew engineering. The SBR rails, they're good because they're kind of loosey-goosey. One of the things is like you can take the block off completely and like run it on the rail again. Whereas this one, if you take it off, you lose all the balls. That sounds like my time at the bar. Just I need to get a drink. Yeah, anyway, sorry. Like we chose this because it's really easy to use because they're like loosey-goosey. They can be like slightly misaligned. They're really forgiving. Just the downside is that they're not as rigid. The other advantage of using the SBR rails is that I think like kind of coincidentally, kind of like probably on purpose, was that if you put the SBR against a flat surface and then you put the ball screw on that the same surface, and you mount all of them together, they all sit flat on the gantry. So you don't need any spacer blocks or anything. It was like Jenga,
path of least resistance.
Not Jenga. Yeah, it was like kind of like super easy to design because you just need to put a bunch of holes in the plate, which is why this design is literally just a plate of aluminum with a bunch of holes in it. There's no spacers or anything. After we started to do like more research and try to understand like the design of things, one of the things that we found was that the price for the HGH rails are more expensive, but given how much more rigid they are, we figured like, okay, well, it's worth the extra cost. That's one of the reasons we switched to it. The other reasons we could switch to it is with our experience with making our own extrusions. So back when we built the Long Mill Mark 1, that's the one with angle aluminum. We kind of like did that because me and Chris, when we designed the first version of Long Mill, we didn't know like how extrusions worked. And that was like a whole learning process. Now we've like made so many extrusions. We know what we can expect from that. We know what sort of price points. We know how to like modify the design to fit different elements. We've been able to make different extrusions. So Daniel like designed all these extrusions. So I think he's the best one to tell you guys why it's amazing.
Yeah. So like Andy mentioned, we've kind of become a little bit more familiar with extrusions and a little more comfortable dipping our toes in stuff. You can see this is an example of the Long Mill X-axis extrusion. It's got a funky shape in here. This is one of our first extrusions we've done. Things turned out pretty well, and we understand kind of what tolerances. And now, like we mentioned with the AltMill, we're moving to a profile linear rail. It's very rigid. You know, we can expect very good performance from all the other components that we're using now. The new bottleneck is now the rail design and the rail rigidity. So naturally, the X-axis rail, the Y-axis rails, the table structure needs to be stiff enough and I guess sized correctly so that we can not have that be a bottleneck and it's sort of balanced, we hope. That's very complicated, but you know, we kind of do our napkin math and hope it works out. But anyways, this is the X-axis extrusion profile. If you know anything about like hollow structures, just the very slightest increase in diameter or outer profile size is like an exponential increase in stiffness and rigidity. We've done our math on this and it should be pretty good to keep up with the increased linear rail performance, etc. The other notable features of this are the machined faces that this will have, because we have two planar surfaces that the rails will mount onto. So these will be all nice and aligned and all square with where this will mount onto the gantry plates. And then, yeah, you'll have your ball screw sitting in here, and we've got this offset to deal with that kind of mismatched height thing that Andy was talking about just now. That's also another partial reason for the extrusion switch up is significant offset. I think it's like 17 millimeter or something. But anyhow, that's the x-axis extrusion. And then this is our y-axis extrusion that Andy was demonstrating. And then that whole structure comes bolting together via some cross-beam members that will support your waste board and any T-tracks and stuff. And that will just assemble like this. It's very uncertain how much time this will take to assemble, but this system is designed to just be a kind of Lego set that you can bolt together your x-axis with your y-axis rails, put your table together, and you're done. Obviously the long mill is like a completely build from scratch process, and we really stand by the fact that you should build your machine to understand how it works, and when it comes to precision components like this, we have to kind of align and assemble these ourselves, but you'll still get the familiarity and process of building it, just maybe not in the same length of time.
So there's a couple of things that we learned from working on the long mill. One of them is like the actual way we process the rails. As we were talking about earlier, like one of the reasons why we don't build a 4 foot by 4 foot long mill is just a skewing. We kind of made the extrusions solve the problem. So we have like a lot of experience cutting aluminum rail really, really accurately. Basically the way that Daniel had it set up was you have the Y rail, and then you have the cross beams, which are cut to an exact length. And then because they go like this, and then the cross beams go like this, they can straighten the rails out over a certain length. The truth of the matter is that extrusions, they have like bends, they have twists, they have like deformation as it gets extruded. They're really precise for what they are, but when we're talking about CNC machines, we're dealing with like sub-millimeter accuracy that people won't be able to see by eye. We know that if we assemble this correctly, it will all pull itself together to be really, really accurate. Like the whole structure is straight, but when we go to extrusions, which are more rigid, can add features that you would otherwise have to cut into the metal, which would make it a lot more expensive. We kind of like took advantage of like our ability to actually cut the rails to exactly the right length, and then understanding like what sort of twist and bend there would be on an extrusion to kind of compensate assembly process to straighten it out. And also to add to what Daniel was saying, the assembling the linear guides, they're more complicated, like the square ones, and we've probably we put together thousands of Z-axis parts for the long mill's Z-axis. There's a whole bunch of stuff that we learned from that, like how the bend of the plate affects the bend of the rail, and how much skew there can be between each linear guide, and what sort of binding you're going to get, and so on and so forth. The fact of the matter is, when companies build machines like this, a large portion of the cost that people have to pay for is in the assembly of the machine. Our challenge isn't just to build a machine that performs well. If we wanted to make it affordable, we also have to be very considerate of the way it gets put together. We could probably build like a design for a machine in like a day, but to make a machine that we can produce in high volumes takes months. Like that's like where all the majority of the effort goes into, because like the features like the edge where the machining is done, that gives us a reference point for where the rails are going to go, as well as like fixturing. And like the process of doing different surfaces in a certain way also ensures that the parts can fit together properly, but without over tolerancing and spending too much on the things that don't matter as much. But yeah, there's a lot of thought that's gone into it to make it as good as it can be. It's kind of like a rundown on the rail stuff. So I'm guessing the big question people are dying to know is, how much is this all going to cost? The price for the machine,
the bare bones,
the mechanics, which include the electronics, the controller, the motors, the ball screws, the linear guides, the frame, everything to like basically build the machine, will cost around 3,600 Canadian dollars, which should work out to about 2,650 US dollars. It basically gives you everything. The only thing you need to get will be a router or spindle, and the waste board, which you can mount to the top of the machine with some screws. You'll need like a 4 foot by 4 foot sheet, so half a regular size. You basically need one sheet of MDF and a spindle, and we'll probably have like a dust shoe option or some sort available as well. In terms of accessories, most of the long mill stuff should work, mostly the touch plates, and the inductive sensor will come included with the machine, because I think in this scale you probably want them. The strategy that we're taking in terms of pricing is sort of similar to the way that we did for the long mill at the very beginning. When we first released the long mill Mark 1, it was basically like half the price of the machines that it was like kind of other similar machines. What we found was a lot of people were like, wow, this machine is so much better than the stuff that's out there right now. And I think part of the popularity when we started out was the fact that the price point was really good. And it's kind of the same situation with the AltMill. With our general research, if you want to get something like this on the market, you're probably going to pay about double, roughly double, give or take, depending on the configuration and stuff. But I think this is going to be a really competitive price point. We've kind of worked it out so that it'll be sustainable as a company to continue to build them. So that'll be good. In terms of shipping, they'll probably be broken down into 3 boxes, basically like 3 48 by the 48 extension boxes, which cost about $30 to ship within Canada and the US. So I would ballpark probably like $100 to $200-ish to ship everything. It will be a much heavier, much bigger machine. The way that we try to do it is like make it efficient, as we did for the long mill. It'll be a very, very affordable machine. The AltMill is actually already in production. We're building 50 units right now. The parts for those will probably show up in the next 2 months. Our best guess in terms of when the first fully working units are ready to ship is gonna be maybe February or March. We're gonna get some of the parts express shipped to us to speed up the process of like testing and prototyping and stuff like that. We're already pretty confident in the design, and the cost to like buy most of the parts is not super crazy at our scale now. Well, if we're gonna commit to it, we might as well commit to building the 50 units, and those will be for sale. The question is, should we sell them right now? Are people gonna be like, we need to get these machines ASAP, take my money right now? And then we'll be like, okay, well, we're a business. We need to make money, and getting the money earlier is better than getting the money later. So maybe we will take the money now. Or if people are like, oh, we want to see what the machine can do and what it looks like when it's all there, then we'll give you your money. Then that's kind of like the other option. I mean, we're prepared to do either way. But I remember like when we launched the long mill, people were like pretty excited to hand over money for the machine. Because one, I think we already had a pretty good track record developing the Mill 1. One of the very few Kickstarters that like delivered on time, and we had like continued to build that community. And obviously the long mill community is like much, much larger now. I think we have like 8,000-ish people. I feel like the 50 units probably won't last long, but if it doesn't, then we like completely missed the mark on what people wanted, and it won't be a viable product. So if you do want to get the AltMill ASAP, I'll put out a survey that'll be like, here's how, basically to answer how interested people are in ordering the AltMill earlier, because the more confidence people have with the product and like want to get it earlier, the bigger we can make the batch. But we could make like 100 units or 200 units. We could make more units based on how many people actually want them. It'll give us more confidence that we're not doing this for no reason. It's cheaper to build a bigger batch for these machines, the larger the batch is, so it's kind of a win-win for everybody. I have some like anticipated FAQ questions, so we can probably answer those. Will the AltMill be compatible with the spindle?
Yeah, so the long mill, we've had lots of people interested in a spindle. A lot of our users do use a spindle. We've kind of routinely taken the stance of like the average long mill user or hobby CNC user, you're probably not going to fully utilize the whole power of like a small trim router like in the Makita or the DeWalt or something similar. You know, when you get to these higher performing machines and you have rigidity to back up the cuts that will bog down your spindle, it is sort of a requirement almost. If you're doing light, gentle kind of work and you just need the space and you need the reliability, you might still be a better fit with a kind of Makita trim router or the DeWalt trim router. So those will be supported obviously, and that's just a cheap entry option. But obviously, yeah, a spindle is kind of a must-have for some people in this category. So we will be supporting obviously like a standard 80 millimeter size spindle. We'll have the mounts available for that. It's kind of TBD, I guess, on how you'll go about getting your spindle. We might be working with some kind of spindle reseller that you might already know about, or we may have our own spindle offering, maybe ready by then. You've maybe heard Andy talking about the CNC Labs router / spindle project that's kind of going on in the background too. You'll probably hear more about that, but the short answer is yes, we will have spindle options available and hopefully reasonably cheap.
Yeah, me and Johan are working on the CNC router. I don't think we have like a name for it yet. With like the stuff that we're developing, it'll be probably powerful enough for this and the long mill while being in like a small enough form factor and the power usage. So that'll be like an affordable option there. But yeah, spindles, like we are developing specifically with spindles in mind because the machine will be able to run much faster and the Makita won't be able to keep up.
Also mention maybe, auto tool change spindles have always been a very frequently requested feature item. A lot of these are kind of emerging in some of these like spindle resellers and other people making their own kits available. So this has always been an issue for most controllers. Like Gerbil is the most basic control system that a lot of these hobby CNCs use. You may have also heard we're switching controllers now. We have a new super longboard controller coming out, which is actually Gerbil HAL. And that has a lot of features that are very applicable to auto tool change that actually make that possible. So you can have a stored tool change macro on an SD card on your controller or stored locally on your controller, and you can tell the machine change to the tool 2 or etc., and it'll automatically run that on the control board itself, do the tool change, everything will be smooth. There's all kinds of inputs, outputs, etc. necessary to make that happen. I can't say for sure if that's something we will be supporting right now or in the near future, but it certainly is possible with this new platform.
My next anticipated question will be, can I upgrade my long mill to an alt mill? Do you want me to? I'll answer that. So the short answer is no. Basically, between the two, there's going to be so few components shared that I would say like the only major components that might be shared are the screws and maybe the couplers. Yeah, it depends. Basically, the answer is no. You won't be able. They're completely different machines. That being said, I do think that some of the development that goes into the alt mill can actually trickle back down to the long mill. You know, we're kind of working through more of the higher level features with this. Well, basically, it's like people can afford to pay for more features at this level, and we're like using that as a budget to do those sort of things. In terms of our goal to make the technology more accessible, if we can scale it down for both the long mill or the alt mill, like we would always take that opportunity. So yeah, like for example, like the closed loop steppers, those are like in the same form factor as the long mill. Potentially, we could have that as an option for the long mill.
A lot of the spindle support probably will overlap.
Yeah, so, and we are like, Johan was testing the spindle support for the super longboard yesterday, and it seemed like it was working pretty well. So yeah, there's like a lot of overlap in terms of the technology side. In terms of the hardware specifically, no. It's a win-win for everybody, you know? People who get AltMill features will get, like, there's like a cross-pollination of features and technology happening here. The next unanticipated FAQ question is, will I need to assemble the AltMill?
Yeah, so we sort of answered this before. Kind of unknown right now how pre-assembled a lot of these things will be, but you can be assured, obviously, the linear guides, like we talked about, are going to be pre-installed. Everything's going to be pre-aligned. The ball screws are going to be pre-installed. So that basically makes up like the main core components is the X-axis, like we said, the 2 Y rails, and you'll need to assemble the cross beams and table structure yourself. Obviously, we can't ship it in this form.
I think like the way that I'm anticipating it to be is the main components will like be put together, and then you just need to like screw everything together into the shape that it is. I think overall it's probably going to be less assembly than the long mill, because a lot of the time for the assembly comes down to like putting together like lots
tiny
of small things. This one is like you take all the small things are already put together and you put together the big things. Yeah, I would say like 2 to 4 hours is probably pretty conservative. It also comes down to like how we want to package it too. If we can make it's kind of like a trade-off of like, we can assemble it here, but it will we'll have to pass the cost off to the customer. But if the customer if it's a hobbyist machine, it's like, the best way to say it is like the time is worth a different amount. Those are things we're considering, and also the form factor of the shipping. But yeah, overall it should be like much easier to put together than the The long mill. Will there be a 4x8 AltMill? Will they come out in different sizes?
We get just as many requests for 4x8 machine as we do probably a 4x4 machine. Obviously, you start growing and you do bigger jobs with full sheet sizes that are 4x8 or maybe even 5x10, and you have that as a requirement. Unfortunately, it's like kind of in the realm of what Andy was talking about before, is you grow your machine and now all these manufacturing and assembly tolerances grow at like even faster. So it's kind of hard to keep up with keeping your table square, keeping your table relatively flat and from skewing when you have a full 4x8 machine. There's also the other big hurdle, which is shipping. Obviously, we can't ship an 8-foot long package. Well, it'd be really expensive. A lot of machines in that category tend to either freight the entire giant machine and you pay an arm and a leg for that, and the machine's probably like $50,000, or you can join 2 shorter sections together, and that's kind of its own engineering assembly challenge on its own. I guess the short answer is like, at this time we don't really have any plans for that, but it's absolutely possible with a bit more work, and I wouldn't be surprised if we did pursue something like that, just not anywhere in the near future.
Yeah, we can work on some stuff that we can make to build it larger. Obviously it has its own challenges, but they're not like impossible. Will the AltMill be compatible with some of the accessories that we have, such as the Vortex, the laser beam,
Dust shoe,
touch plates,
yeah.
SLB, things like that?
So obviously like laser, Vortex are going to be like pretty straightforward. They're going to be very adaptable and work fine with this. There's some other stuff like the dust shoe is specific to the long mill Mark II, and that obviously won't be compatible. We will have a different alternative dust collection accessory, probably TBD at later time. I think Andy mentioned previously, induction sensors or limit switches will be a standard feature for this. Just because of the nature of the machine, you kind of just want these, even if we do have closed loop steppers. SLB has a potential computer option, add-on option, so it'll kind of be a standalone device that will let you sort of have it all in one unit on your machine rather than have a second laptop or something.
So if you like follow the Instagram and stuff, I like put some videos of basically like a CNC tablet, and it's got like a computer on board and you can use it to control the machine. And it's supposed to be tied in with the SLB, so it's like a standalone unit. Those are like built for any type of CNC machine, like either long mill or AltMill. Everything that's developed around that will be developed around like this as well, so they're equally involved in that way. There are like specific long mill hardware parts, like the dust shoe and the dust shields and stuff like that, but a lot of the stuff are interchangeable, and they work on like the same electronics platform for the control and things like that. Any of the improvements that you will see with the long mill, you'll see trickle into this as well. I'll put out more information about the computer stuff. It's a whole big party.
I guess like one other thing to mention regarding accessories are new accessories that will be introduced maybe for the AltMill. It's kind of not finished yet, but we will have table legs most likely ready for this type of machine, going along with the theme of this being a kind of fully enclosed like standalone kit, not relying on a table and a wasteboard setup already. So we wanted to be able to have this be a freestanding structure you can just set up if you don't have a table ready, if you just have space for it. You'll see more details about that later on. There's some other accessories that might be a little bit more fitting for like a kind of prosumer sort of machine that might be used for production that people want, such as like a vacuum table, tool changing like we mentioned before. Those really aren't on our radar right now just because kind of outside, teetering on the scope of what this machine is meant for. Who knows what the future has? You never know. Like we were talking about, that's just a kind of old prototype for the original iteration of the AltMill. Pretty major design changes with different linear rails and different extrusion profiles for all the axes. These are our linear rails like we were talking about, and the offset for our ball screw, and then the cross beam table mounting setup here. We can also have this plate here and take a look at the x-axis gantry. So it's a little bit busy, but kind of like what we were talking about before, these rails will sit on a machined reference edge, and you should have pretty good alignment with everything out of the box. 80 millimeter spindle is being very much accounted for here. You've got lots of travel, so right now this will have a 6.5 inch of Z-axis travel, and you'll have about 4 to 5 inches height under gantry. That's kind of pending right now, but you'll have plenty of clearance for slab flattening and other things like that. And you can see this is using the standard NEMA 23 motors and mounts for those motors. So like we were talking about, these are kind of just interchangeable, and you might see these as an option maybe for long mill in the future.
Maybe how you mount the waste board to the machine.
So you'll have some options for doing this. Basically, a lot of people might want to use a T-slot and mount their waste boards from the top. Some people might want to do this from the bottom. So we kind of have both options there available for you. We have these machined holes in these cross beams that will allow you to go underneath the table. You'd probably do this before setting it up on a stand. So you might lean this against a wall and set this up and do this. And you can just drill in to these cut slats and not worry too much about hole position or anything. If you're kind of more meticulous and you just want these done maybe nicer looking, you can go in from the top and pre-drill your holes on the top surfaces, add a little counterbore or countersink, and then you can have these go into a T-nut in this top T-nut. The other thing about this too is that this allows you to change the widths of your slats. So, we've had like a lot of feedback with our long mill and our T-track set for that. We recommend a certain slat width, but ultimately it's dependent on what you're going to be doing. Some people like to have T-tracks that aren't like consistent spacing. They want them more dense in the center or something for more flexibility. This is a lot of just like letting you kind of figure out what works best for you. If you want to just slap an entire MDF sheet across the entire table and never deal with T-tracks either, that's completely an option. That's probably what I would do personally because I'm lazy. But yeah, I think that basically covers
the legs.
The legs.
I'm just here for support.
Yes, and the reminders. This is what legs might look like. These are probably going to tend to be some sort of sheet metal design, just because we want to be able to offer these at the lowest cost possible. I would target these being maybe no more than a couple $100, like maybe $300-400, I don't know.
For the table legs?
Yeah, maybe cheaper.
I feel like they could be a lot cheaper.
Okay, let's change that to like maybe 200 or so.
Yeah, I mean
maybe even less.
I mean, it can kind of be like stumps of wood.
Yeah.
The legs are like they don't add any structure. It just keeps it off the floor.
Exactly. Yeah.
So
yeah.
I mean, if you took I feel like if you just took a post and you cut them to the same height.
True.
You would literally be fine.
Yeah.
You just need like a plate to mount it to.
Yeah.
But yeah.
Yeah, no, that's possible.
Off the wall.
Anywho, yeah, this is what it could look like. Like we said, this is kind of a pending accessory option. You'll maybe see some other things like obviously self-leveling feet for the bottom if your floor is uneven. Some kind of like options for adding a shelf for material storage, things like that. So not too much to talk about there, but it's certainly will be an option in the future.
I think that pretty much wraps it up. If you'd like to learn more, we'll have more detailed information on the blog. Yeah, at this stage, we just wanted to share everything that was happening with the AltMill and what it is. And we kind of want to get this time to judge what people's interests are so we can predict and plan out our production for the next batch of machines. We'll have a survey in there if you're interested in ordering. Feel free to send us a message, give us some feedback, let us know what you're looking for. I guess that wraps it up. Bye-bye.
Bye, guys.